Morning, guys. Okay, so your homework was just to get the experiment written up to kind of a point where if we were to go into school tomorrow, well, maybe not tomorrow because it's Saturday, but if we were to go back into school, that you'd be ready to kind of read over the experiment. That would jog your memory. You'd have your table ready to be filled in, and you could then take your data, draw your graph, and conclude the experiment. Okay, so that's kind of how I wanted you to leave it, just ready to be done. And then when we go into school, we'll be able to, I think I added it in here. Yeah, I have them in here. So we have to do the exothermic and endothermic reactions. And then the next one is investigate if. So surface area is the one that we talked about there on Tuesday. Okay. So today I want to do, so there's the first factor that affects the rate of reaction is surface area. The smaller the pieces you use, the more surface area has been revealed, and as a result there is more area for the reaction to take place on, so the reaction happens quicker. Okay, now we haven't obviously done the experiment to prove that yet. We will. And the experiment we're using is the production of carbon dioxide experiment, where you mix calcium carbonate with hydrochloric acid. It produces carbon dioxide and we catch the carbon dioxide. And then all we're going to do to prove that surface area has an effect is that we're going to make the carbon, kind of initially cut the calcium carbonate into smaller pieces and then crush the calcium carbonate into like really small pieces, and watch how much carbon dioxide we can catch in a 30-second period. Okay, so today we're going to look at the second factor affecting rate of reaction, and the second factor is temperature. Okay, so temperature has an effect on rate of reaction. When you add heat, okay, remember that heat is energy. So when you add heat to any reaction, you're basically giving all of the particles more energy, okay? And specifically, the type of energy that you're giving it is kinetic energy. Do you remember what kinetic? Sorry, I cannot. I don't seem to be able to hold a straight line today. Okay, there you go. I'm going to do one more bit. This bit here. Okay, so as heat is added to the reaction, the particles that make up the reactants gain more kinetic energy. Okay, so heat is a form of energy. When that heat is distributed to the reaction, it's given to the two reactants, so the two things that are reacting together, and it makes them, so you know the way energy can be converted into other forms, it gets converted into kinetic energy. And if you remember, kinetic energy is moving energy. So then the particles move around faster. Okay? So essentially, what this does is it means that the particles have more energy. So when they when they collide, they're more likely to have, do you remember what they're called? They're more, oh no, didn't mean to do that, sorry. Hang on, apparently I can't multitask. They're more likely to have what are called effective collisions. Remember we talked about them? I'll write that whole sentence actually. So they are more likely to have effective collisions. Okay, effective collisions mean that when they collide, they will react. Okay, they won't just bounce off each other. So you give them heat energy, that heat energy gets converted into kinetic or moving energy in the reactants. So now the reactants, which are all bobbing around and hitting off each other, are hitting off each other with more energy, which means they're more likely to have effective collisions. And effective collisions are ones that have achieved the activation energy, which means when they collide, the reaction will actually occur and the products will be produced. Okay, so I just want to show you this. Actually, I might just go, yeah. Okay, we've used this before, you know, the PhET simulations. Okay, this is a nice one. So, you don't really need to understand too much of what's going on here. What I have here, okay, I'm reacting A with BC, okay? They don't mean anything. So that's like reacting your calcium carbonate with your hydrochloric acid, okay? So what I've done is I'm going to put 10 molecules of calcium carbonate and 10 molecules of hydrochloric acid into the experiment, okay? And down here, you're going to see the number of effective collisions that take place. Okay, I'm going to do it for like a 20-second time period, let's say. Okay, so let's watch. Okay, hang on. Nothing is happening. Let me just reset that. Reset. What did I do? Oh, sorry, I had it like... Okay. Okay, so we have 10 and 10. I'm going to begin the experiment and I'm going to reset the timer. Okay, so you can see the particles moving around here. They're moving quite slowly. They are colliding. See them colliding? Okay, they're bouncing off each other. But hang on, we'll stop. So we're up at 8 seconds. So can you see that they are bouncing around? They're bouncing off each other. 13 seconds, 14 seconds, right. So I went over 15 seconds. Now look over here. Okay, these are the products. Okay, so I had 10 reactants, I had 10 of the calcium carbonate, and I had 10 of the hydrochloric acid. Those particles were bouncing off each other and colliding. I mean, they're still doing it, but we are getting no products being formed. And that is because those particles do not have enough energy to have reached the activation energy. So all of those collisions are not effective ones. They're not actually triggering a reaction. Now, I'm going to reset the timer and I'm going to increase the temperature. Okay, so I'm just going to halfway there. Still 10 and 10. Now, the first thing I want you to look at the speed the particles are moving at. I have put in all this heat, that is energy that I'm giving to the particles. In the particles, that kind of transpires, or how that gets converted is that they're moving more quickly. Okay, so we'll begin and start. Okay, look how much more quickly they're moving. Okay, still colliding all over the place. And look, already I have products being formed. Look. Okay, because they're moving with so much more energy, because I gave them that heat, they move with more energy, so there's more effective collisions taking place. Okay. Oh, I actually stopped it at the exact same time. So the difference here is that when I gave them some heat energy, so I heated them up, that gives the particles more kinetic energy or moving energy. So when they collide now, it's like, I suppose it would be like the difference if, you know, two cars were moving really, really slowly, like maybe a car trying to park, and they just bumped off each other and absolutely no damage was done whatsoever, compared to, you know, two cars moving incredibly quickly. The collision is just so much more dramatic, and it's the same thing here. You get a more effective collision, and as a result, the particles have enough energy. They have the activation energy, so they have enough energy to react and form products. Okay, so what's happening there is, by putting the heat in, you are encouraging the reaction to happen more quickly. Otherwise, you'd have to wait around a long time for those reactions to start to become, you'd get lucky. One of them would bounce off a wall of a container, come back with enough speed, and you'd meet the activation energy and you'd produce a bit of product, but it would happen very, very slowly. By inputting the heat, you increase the speed of the particles, and as a result, you actually increase the speed of the reaction. So the whole reaction happens quicker. Okay, so how are we going to prove that? The experiment we're going to do is actually the exact same experiment. Okay, this one again, the production of carbon dioxide. So I've called it the extension experiment. We're going to investigate how the temperature of calcium, that's wrong, sorry, how the temperature of hydrochloric acid affects the rate of production of carbon dioxide. Okay, so it's the same experiment. We're still going to produce carbon dioxide, so we're still going to mix together calcium carbonate and hydrochloric acid, and we're going to produce the carbon dioxide in the inverted gas jar, and we're going to time it for 30 seconds. But this time we're going to use the same calcium carbonate every time, so we're not going to change the size of the chips. We're going to keep them the exact same size. So it doesn't really matter whether you go with the big ones or the middle ones or the powder, but it has to be the same. Okay, so that's going to be really, really important. Size of calcium carbonate chips will stay the same. Okay, so we'll probably just go with the biggest ones because they don't have to be manipulated. That's just what comes out of the packet. So that's probably what we'll go with. So essentially, I don't want you to write out the apparatus again. I just want you to say same as above with the addition of. So you'll see down below, we're going to need a water bath. So we're going to need like a hot plate and a water bath to heat up, essentially. So you'll have to add them, and then you'll also, again, I don't want you to redraw the diagram, but I need you to draw the new bits. Okay, so you'll need to draw a hot plate, you'll need to draw an additional conical flask, and show the conical flask on the hot plate. Yeah? So the method would be refer to the results of the first 4 steps of the above experiment. Okay, so if I go back up here, the first 4 steps was placing 20 grams of calcium carbonate into a conical flask, adding 50 cm cubed of dilute hydrochloric acid to the calcium carbonate, collect the gas produced in an inverted gas jar in a basin of water in a 30-second time frame. Okay, that's going to be your control. Okay, so we won't do that again. You'll just take the results from the previous experiment, what volume was produced. Okay, then what you're going to do is you're going to do the experiment again, but before you put the 50 cm cubed of hydrochloric acid into the calcium carbonate, you're going to put it in a different flask. So you pour the hydrochloric acid into a different conical flask and place the flask in a water bath at 20 degrees Celsius for 5 minutes. So we're introducing that heat energy, we're upping the temperature. Once the hydrochloric acid is up to 20 degrees, you're going to add it to the calcium carbonate, and then the same thing, how much carbon dioxide is produced in 30 seconds. It should be more, because you've heated it now. And then what we're going to do is we're going to heat it to 30 degrees Celsius. So we're going to take our cool, normal hydrochloric acid, we're going to put it into the water bath, and we're going to heat it up to 30 degrees Celsius. Once it's at 30 degrees Celsius, you'll need a thermometer in your apparatus. Once it's at 30 degrees Celsius, you put it into the calcium carbonate, and 30 seconds to get as much carbon dioxide as you can. It should be more. Making it hotter and hotter and hotter should increase the rate of production of carbon dioxide because those particles are moving faster, so they're having effective collisions and they're making loads of product. Okay? And repeat the above steps using water baths at different temperatures. Okay, so your control, this is your control. Oh, I can't edit that because I did it on Word. That's your control. Would take that from the previous experiment. And then you would do your 20 degrees Celsius, your 30 degrees Celsius. I'd probably, if we were in class, do a 40 and a 50. So that's how many bits you're going to need in your table. 1, 2, 3, 4, 5. Yeah? And then same again, put a heading for your graph, put a description for your graph, but you're not going to be able to draw it at the moment, so just leave a space. And the conclusion, you can write it, but where there is a question, leave space for the answer because you can't answer it until you've done it. And the precautions are the same for this experiment as for it's the same experiment essentially. So wear safety glass to protect your eyes while working with the hydrochloric acid, probably more important when you're heating it. Avoid skin contact with any of the chemicals. I suppose you could probably add in a third one. You will be working with a hot plate, so be careful. You know, a hot plate is hot, obviously. Don't put your hand on it. Okay, so that's it. So the second factor affecting rate of reaction is temperature. So take down the notes on temperature. How does temperature affect rate of reaction? What does it actually do? So that's all that stuff about introduce heat energy, you're going to increase kinetic energy, and as a result you have more effective collisions. An effective collision means it's a collision where the reactants actually produce product. Okay, as in the reaction occurs. Then for homework, I want you to write up this experiment in the exact same way you wrote up the other one on Tuesday. Okay? All of this is fine. Like you can say same as above experiment. You know, you don't have to rewrite the list of apparatus. You don't need to redraw the diagram. You just need to draw the new bits. So the new bits of apparatus are going to be a hot plate, another conical flask, and a thermometer. I think that's all you're going to need. Okay, possibly a tongs, you know, to hold the top of the conical flask when it gets hot. So just, you know, the reason I'm coming up with these is because I'm thinking through how I would do the experiment. So you will need to make a list of the additional apparatus and draw a picture of the additional apparatus. The method will have to be written as it is. Oh crap, what did I just do? There you go. The table will be drawn, and I would say leave space for 1, 2, 3, 4, 5 sets of results. So I obviously only have space for 3, so make it a bit bigger than my table. Leave space to draw a graph. So that's, I mean, drawing a graph, that's a good half page. Okay, so leave a good bit of space. And then your conclusion. So you can write your conclusion just when you write out the question, like what was the outcome of the experiment. Leave a line or two for the answer. Okay, so that's your homework for Tuesday. Okay, let me know if you have any questions. I'm actually going to, just before I sign off, I'm going to put it in here. So homework for Friday is write up experiment for how temperature affects rate of reaction. Okay, and we'll have all these ready in our copy, ready to go. And we're just going to have like 2 solid weeks of experiments when we go back, which will be nice. Right, have a great weekend, and I will chat to you on Tuesday.